Okay, so here's the first problem in section 5-2. I couldn't go through the steps with you, which are the 5 steps for problem solving. Know what you know what you're looking for, find a way to solve it, and then make sure you answer the question. The table on page 162 is also helpful to tell us how to translate different ideas. In this case, the problem that we've got here, it gives us the difference, and if you notice in the words, difference is subtraction. If the difference is 4 per day and part-time employees work 6 hours per day, how many hours per day do full-time workers work? Okay, so we're going to take F will be the number of hours full-time workers work. Okay. F is part-timers plus 4, because it says the difference is 4, which I suppose we could have done F minus P is 4. Okay, and it says that part-timers work 6 plus 4, so full-timers work 10 hours per day. Okay. Next, Jill has 3 times as many trading cards as Matt. So M is going to be number that Matt has. The number that Jill has is going to not be J. We're going to use the letter M. It's actually 3M, though, because it says 3 times as many. If the total number, so total means add them up, 3M plus M, that's Jill, right? Plus Matt is 200. How many does Jill have? So 4M is 200, which means M is, divide both sides by 4, is 50. She is 3 times 50, so Jill equals 150. Try this one. Full-time employees at Charlie's Steakhouse work more hours per day than part-timers do. If the difference in hours worked is 4 hours per day, and if part-timers work 6 hours per day, how many hours per day do full-time workers work? Well, this is the one that we just said. We'll let F be the number of workers, number of hours that full-timers work. Full-timers minus part-timers, which is 6, is 4. Add 6 to both sides. Full-timers work 10 hours. Diane's card shop spent a total of $950 ordering 600 cards from Wits End Company, whose humorous cards cost $1.75 each and whose nature cards cost $1.50 each. How many of each style of cards did the card shop order? Okay, we're going to make a chart to help us solve this problem. We've got the number, we've got the price, and we've got the total. Number times the price is the total. We've got natural cards and humorous cards. Okay, and then we've got the total number of cards. We know that these cost nature cards cost $1.50. Humorous costs $1.75. We don't care how much that one is. We do know that we spent $950 and we got 600 cards. So let's let N be the number of natural cards. Then the humorous ones is, now let's think about this for a second. Since the total is 600, Humorous will be 600 minus n. So this will be 1.5n. I multiplied these two together. This will be, now I'm going to have to multiply in my calculator, 600 times $1.75. And I get 1,050 minus 1.75n is 950. So my total is 1.5n plus, I'm doing this column over here, 1050 minus 1.75n equals $950. I'm going to subtract 1050 from each side. And $1.50 minus $1.75 is negative 0.25n equals negative 100. Divide both sides by negative 0.25. 100 negative divided by 0.25 negative is 400 natural cards, which means since the total is 600, there must have been 200 humorous cards. Wanda plans to save 1/10 of her salary each week. If her weekly salary is $350, how much will she save each week? S equals saved. Okay? It says S is 1/10 of means times the salary. Well, 350. So if we press that on our calculator, we get $35 is saved each week. Denise ordered 75 dinners for the awards banquet. Fish dinners cost $11.75. Chicken dinners cost $9.25. She spent a total of $756.25. Okay, so once again, we've got the number, the price, and the total. And we've got chicken, and we've got fish, and we've got the total. Okay, there were 75 total dinners. Let's call this C. This will be 75 minus C. Fish dinners cost $11.75. Chicken dinners cost $9.25. And she spent a total of $756.25. 9.25C, when you multiply that, 75 times 11.75 is 881.25 minus 11.75C. Okay, let's add up this column here. 9.25C plus 881.25 minus 11.75C is 756.25. Let's subtract 881.25 from each side. And we get, this is negative 125. These cancel. 925 minus 1175 is negative 250. So divide C. Divide both sides by negative 2.5. And we get C is 50, which means the fish dinners is 25 because they have to add up to 75. Many times a problem requires more than one unknown value. Our strategy will be to choose a letter to represent one unknown value. It's usually the second one listed. For instance, if we know that twice as many men as women attended the conference, we would say W is our unknown, and then men would be 2M, or 2W, excuse me. In planning for a conference on successful business practices, the organizer are anticipating that twice as many men as women. So W is women. Then M is 2 women. If they are expecting 600, so women plus 2 women is 600, or 3 women is 600. So the number of women, divide both sides by 3, is 200, which means the men is 400 because they have to add up to 600, plus that's twice as much as 200. The relationship between two factors is often important and describes a proportion. The label of a container of weed killer gives directions to mix 3 ounces for every 2 gallons. How much would you add for 5 gallons? Notice I put the gallons on the bottom, so my answer is going to be in ounces on the top. How many ounces is that? Well, we find the answer by cross-multiplying this times this, divide by this. So on our calculator, we would press 5 times 3 divided by 2, and we get 7.5 ounces. Oh, this one we just did. Increase or decrease. Your car gets 23 miles per gallon, miles to the gallon. 23 miles is 1 gallon. How far can you go on 16 gallons? Notice I put the gallons next to the gallons. Cross multiply and divide. 16 times 23 divided by 1 is 368 miles. And that's the one that we just did. And we